Hi, I'm Shyamala Gauri, Assistant Professor in Rohini College of Engineering and Technology. CS 3352 Foundations of Data Science. Unit 4 Python Libraries for Data Wrangling. In this presentation, I'm going to explain pivot tables in Pandas. Pivot tables. It creates a spreadsheet style pivot table as a data frame. The levels in the pivot table will be stored in multi-index objects or hierarchical indices on the index and columns of the result data frame. Here is the syntax of writing the pivot tables in pandas. See pandas.pivot tables of and the parameters are specified here. Here I am going to explain the parameters in the syntax. Here first one is what? Data. Data is a data frame. And second one is values. Values are list like or scalar or optional. Column or columns to aggregate. Next one, index column. It is a grouper, array or list of the previous. If an array is passed, it must be the same length as the data. The list can contain any of the other types except list. Keys to group by on the pivot table index. If an array is passed, it is being used as the same manner as column values. Next one is how to specify the columns. It is a column or grouper array or list of the previous. If an array is passed, it must be the same length as the data. The list can contain any of the other types except list. Keys to group by on the pivot table column. If an array is passed, it is being used as the same manner as column values. Next one is aggregate function. It is a list of functions dit or default numpy.mean. If list of functions are passed, the resulting pivot table will have hierarchical columns whose top level are the function names inferred from the function objects themselves. If dict is passed, the key is column to aggregate and value is function or list of functions. If margin is equal to true, aggregate will be used to calculate the partial aggregates. Next one, fill value. It is a scalar or default by none. Value to replace missing values with in the resulting pivot table after aggregation. Next one, margins. It is a type of bool. Default value is false. If margins is equal to true, special all columns and rows will be added with partial group aggregates across the categories on the rows and columns. Next one is drop any. It is of type bool. Default value is true. Do not include columns whose entries are all nan. If true, rows with nan value is any column will be omitted before computing margins. Next one, margins. Name str default all. Name of the row or column that will contain the totals when margins is true. Next one is observed. Its data type is bool. Default value is false. This only applies if any of the groupers are categoricals. If true, only show observed values for categorical groupers. If false, show all values for categorical groupers. Next one is short. Its data type is bool. Default value is true. Specifies if the result should be shorted. Here is an example for pivot table. See, here the data frame has been created for 8th column, bth column and c, d and eth column. The data frame has been created. If it is printed, it will look like this. The output for the data frame will be like this, hierarchical data representation. The first example aggregates the values by taking the sum. See here, table is equal to pd.pivot table df. The value data frame has been taken as an input and the values of d and indexes from a and bth column and columns is c. So aggregate function we used here is np.sum_of. So if we print the table, the pivot table will look like this. The output for the statement is like this. We can also fill missing values using the fill value parameter. See here, pivot table and the data frames is taken as an input. Here values and index are specified, column is specified, and then the aggregate function np.sum_of, and another option we have written fill value is equal to 0. If there is a missed value, if there is no value for any particular column, the missed values will be filled by zeros like this. The next example aggregates by taking the mean across multiple columns. See here in the pd.pivot table of data frame is taken as an input and values are taken from D and E. Indices are taken from A and C, and aggregate function we used here is np.meanof for the dth value, and for also E we have taken the mean right for E we have written like this np.meanof. So this is an example for taking mean function across multiple columns. That is, one column is D and another column is E. And here is the output for the above statement. We can also calculate multiple types of aggregations for any given value column. See here the same as the previous one, pivot table. Data frame is taken as an input and values are taken from D and E. Indices are taken from A and C, and aggregate functions for the dth value is dp.meanof. For each value, we have used multiple aggregate functions. One is min function, and another one is max function, and another third one is np.mean function. For each column alone, we have used multiple aggregate functions, min, max, and meanof. The output for this statement is shown here. Thank you.